Hi everyone, this is Babaiah, Assistant Professor of ECE Department, MLR Hyderabad. Now I am going to explain about the what are the special cases are available in the Routh which criterion method or else construction of Routh array special cases. Right, move on to the first here. See overview of today's session. The first case is the normal Routh array. That means the no zero elements or non-zero elements in the first column of the Routh array. And the second case comes for the a row of all zeros. If any row of array matrix is going to be zero elements, that is the considered as the one case. And the next case is here, the first element of a row is zero, but some or other elements are not zero. First element of row is zero, but some or other means at least or else one element or first element of a row is zero, the remaining elements are at least have one value. Right, next coming to the first one here, case 1 normal Routh array. Just to see here, in this condition or else in this normal Routh array case, there is no difficulty to forming the Routh array, and the array Routh array can be constructed as explained by previous. I am explaining one example or nth polynomial equation, that is the previous session. Just to want to just to see that one also. Next, here the sign changes are noted to find the number of roots lying on the right half of the S-plane. Then the system is estimated, and that is the stability systems. When we are going to design any Routh array matrix by using the special case 1 or else normal Routh array method, in that the first elements of first row element or first column elements, or if any changes are there, then we are going to say that number of changes of are nothing but the number of sign changes are nothing but the number of roots of right half of the S plane. So here, if any sign changes are not there for the given any array, so we are going to say that all the roots are lying at the left half of the S plane. That is the stable system we consider. See here, the two cases are here. See, first case, if there is a no sign change in first column of Routh array, then all the roots are lying on the left half of S plane. Then that type of system is nothing but the stable system. In second case, if there is a sign changes are there of first column of Routh array, then we say that the system is unstable system. The number of sign changes are nothing but the number of roots that are lying right half of the S plane is equal to the sign changes simply, right? So the remaining roots are lying on the left half of S plane. These two are the conditions by applying or by using the normal Routh array. Next, coming to the second case here, a row of all zeros, and all zero row indicates the existence of an even polynomial as a factor of the given characteristic equation. Right, from the equation we are going to just see, in even polynomial the exponents are even integers or zeros only. So this even polynomial factor is also called as auxiliary polynomial. So auxiliary polynomial equation is always in the form of even or even terms or even s powers only. So the coefficients of the auxiliary polynomial will always be the element of the row directly above the row of the zeroth row. How to calculate the auxiliary polynomial equation? For that, we are going to take the zeroth row above row is nothing but the auxiliary polynomial. That is the condition, right? So here the roots of an even polynomial occur in pairs that are equal in magnitude and opposite signs. These are can be purely imaginary or purely real or complex. The purely imaginary and purely real root occur in pairs. The complex roots occur in group of 4, and the complex roots have the quadratic symmetry That is, the roots are symmetrical with respect to both the real and imaginary axis. Just to see that polynomial equation, see from this, for example, this pole, this is the imaginary axis and this is real axis. Here imaginary and real, imaginary, real axis. See here, this one is a pole and this one is a one more pole. So two poles are these two poles are on imaginary axis. Those these are the imaginary and not repeated. So that's why this is the stable system, but it is in conditionally stable system or marginally stable system, we say that this one. And this is come to this diagram. Here two roots are, these two roots even polynomial. So even polynomial, two roots here, two roots here, four roots also even polynomial. These all are the diagrams of even polynomials. And I see here, if two roots, one is the left half of the S plane, one more is the right half of the S plane, at least one pole present or one root present at the right half of the S plane, then the system is unstable system. This is the unstable system. Unstable system. Here this one is the marginally stable system. Here see, two roots are again in right half of the S plane. So right half of the S plane. So this system also unstable system. Unstable system. So this is the case 2 polynomial, can be analyzed by one of the following two methods. The two methods we are going to use in the case of 2. So see, first method. In first method we are going to determine the auxiliary polynomial equation, that is the zeroth row above row, and differentiate that auxiliary polynomial with respect to s to get the this a of s divided by d of s. The second point, the row of 0 is replaced by the coefficients of differential equation of the auxiliary polynomial. Next, the fourth, continue the construction of the Routh array in the usual manner, and as the case of 1 we need to follow in that condition. And then array is interrupted as follows, like this. See, first step in this, by continue that construction of Routh array. Here there is a, we need to find the number of sign changes of first column of the Routh array. Then the system is stable or unstable based on the sign changes. If there are sign changes are there in first column, the system is going to be unstable system. The number of roots are lying on right half of the S plane is equal to number of sign changes. That is the important point. Next, the number of roots on imaginary axis can be estimated from the roots of auxiliary polynomial. The remaining roots are lying on the left half of the S plane. Some of the roots are lying on the imaginary axis, some are the left half of the S plane. The third point, if there are no sign changes in first column of Routh array, then all zeros of rows indicate the existence of purely imaginary roots. No sign changes and imaginary axis only, we have a roots, then that is the imaginary roots, we say that. That is limitedly or marginally stable system. Example, this one, limited or marginally stable system. Okay, the roots are auxiliary equation lies on imaginary axis, remaining roots are left half of the S plane, like this, left half of the S plane, imaginary or left half of the S plane. When we are going to write, draw like this. This one also marginally stable system we consider. This is the method 1 condition. When we are going to use the method 2, for the case 2, we are going to determine the auxiliary polynomial equation again, that is the zeroth row above row, and divide that characteristic equation by auxiliary polynomial and construct the Routh array using the coefficients of the quotient polynomial. Here we are going to substitute s is equals to 1 by z, or else the array is interrupted as, just we are going to follow this. If there is a sign changes or there first column, the coefficient, then the system is unstable, sign changes. The number of roots are quotient polynomial lying on right half of the S plane is given by number of sign changes in first column of the Routh array. So that is the if the roots of auxiliary polynomial are directly calculated, find whether they are purely imaginary or purely real or complex based on the uh, roots of the given auxiliary polynomial equation. So here next, the total number of roots on right half of the s-plane gives the sum of the number of sign changes and the sum of the roots of auxiliary polynomial with positive real part only. The number of roots on imaginary axis can be estimated from the roots of auxiliary polynomial. The remaining roots are lying on the left half of the s-plane, definitely. Okay. If second case, if there is a no sign change in first column, here first point there is a sign changes, that is unstable. If there is no sign changes in Routh or a quotient polynomial, then the system is limitedly or marginally stable. Since there is a no sign change, all the roots of quotient polynomial are lying on the left half of the s-plane. In that condition, we are going to say the given system is marginally stable or limitedly conditionally stable system. Here, the roots of auxiliary polynomial are directly calculated to find whether they are purely imaginary or purely real or complex. The number of roots lying on imaginary axis and right half of the s-plane can be estimated from the roots of auxiliary polynomial. The remaining roots are lying on left half of the s-plane. This is the two methods. When we are going to use the condition of case 2, in that we are going to use two methods. In that method, we are going to observe the sign changes are there in first column or not. From that, we are going to estimate the given system is stable or unstable simply. Right. Next, coming to the third case here. In third case, the first element of row is 0. First element of row is 0 in array matrix. Then we are going to see here, or else while we are going to constructing the Routh array, see here, while constructing the Routh array matrix, if 0 is encountered as first element of a row, then all the elements of the next row will be infinite. If any first element going to be 0 in a array matrix, the next row elements values are going to be infinite values. So that we are going to overcome that problem, we are going to assume, or else we are going to consider the epsilon in place of 0. Let 0 in place, let epsilon is in place of 0. We are going to assume and complete that construction array or Routh array in first case, same as in first case. Finally, we are going to let epsilon tends to 0 and determine the value of the elements. Then the array which is in the function of epsilon. So finally, we get the, in terms of epsilon, we are going to construct the array matrix. In that, we are going to calculate the roots or sign changes by placing the epsilon tends to 0 in place of array matrix which we are having any epsilon is there. In that, we are going to consider the epsilon equals to 0 substitute. Then you will get the number of sign changes or not that we are going to observe from the array matrix. This is we need to follow. Same, see here, the first, if there is a no sign changes in first column of Routh array, there is a no row with all zeros, then all the roots are lying on left half of the s-plane, then that system is stable. If sign changes are there are sign changes, so of first column of Routh array, then no row with all zeros, the some roots are lying on the right half of s-plane, the system is unstable system. The number of roots lying on the right half of s-plane is equal to number of sign changes and remaining roots are lying on the left half of the s-plane only. For example, for third condition, if there is a row of all 0 after letting epsilon tends to 0, then there is a possibility of roots on imaginary axis. Some of the roots lying on the imaginary axis, then we need to determine the auxiliary polynomial and divide the characteristic equation by auxiliary polynomial to estimate the imaginary roots. The Routh array is constructed using the coefficients of quotient polynomial, and the characteristic equation is interpreted as explained by the previous method 2 of case 2 polynomial. Case 2 polynomial here. Method 2. This is one. Just to calculate the auxiliary polynomial equation and divide that characteristic equation and construct the array by using the coefficients of quotient polynomial, and then we are going to calculate the number of sign changes are available or not. From that we are going to estimate the given system is stable or unstable. These three cases are very important for the RH criterion method or Routh-Hurwitz criterion methods, and this one is the very important for any technical exams also. In Routh-Hurwitz method, from three methods we are going to get the any question also for the any technical exams also. That is the very important. So you have to remember all these three cases. Mostly we say that the case 2 and case 3, these two are the special cases. This one is the normal case. So first case one is the normal case, that is normal Routh array. Then complete row is 0 and the first element of row is 0, then remaining but some remaining elements are non-zero elements in that condition. These two are the special cases of RH criterion method. These are the methods. In these methods, in these special cases, we are going to follow the type of procedures. Consider the auxiliary polynomial and observe the number of sign changes on left side or right side, number of sign changes, or else roots or else poles are present on the left half of the S-plane or right half of the S-plane or imaginary axis. We need to find that condition, and we are going to estimate the given system is stable or unstable system or marginally stable system from these three cases. This is about the special cases of RH criterion method or construction of the Routh-Hurwitz criterion special cases. Thank you all.